And now please join me in welcoming Dr. Harold Schmitz.
Do I need to turn this on or not?
I think you have.
Thank you very much. Can everybody hear me? Good. So thank you very much, Janet, for that welcome. And just to reiterate, we'll do the tasting part as well as the questions after the presentation. I do have a lot to talk to you guys about. A lot has happened in the world of science and chocolate and the science of cocoa in the last 20 years. And I've been fortunate to be part of Mars for most of that time and can comment on that. And actually, we're going to talk not only about the nutrition and medical potential that cocoa offers that is really exciting and really interesting, but we're also going to talk about the role of cocoa in the environment as well as in context of social sustainability a bit as well, because it all ties together. And the way it ties together is that if we aren't able to sustainably grow cocoa, then all these wonderful health benefits that might be there for certain cocoa products in the future, of course, won't be there because it won't be able to be grown properly. So it does all tie together. So a view from scientists on Mars regarding the future of chocolate. Oops, I'm sorry. How's that? Is that better?
Yep, okay. Oh, much better. Much better. Okay. Let me make sure I got the button here right. I do. Good. Okay. So if you are a scientist at Mars, the view you have in terms of chocolate is this. And what this is, these are cocoa pods. And they're about the size of footballs. And it's the stuff inside. These are the seeds. So cocoa is a fruit. It's a tree. It's a fruit tree. Cocoa is a fruit. So it's hard to believe, I know, but it is true. And it's the seeds of the fruit that are the product that is converted into different cocoa ingredients that give chocolate its unique sensory properties. And the white stuff that surrounds the seeds, and the seeds are oftentimes dark purple, but this white stuff is very, very sweet and is actually converted into a beverage in some parts of the world, like Brazil. That's really interesting. So I'm going to talk to you about many people, when they talk about chocolate, everybody has a preconceived notion of what it is, and it elicits giggles. And the last thing you think about chocolate would be something like this organization called DARPA, that's the Department of Defense Fundamental Research Group, who does things really, really that would be called deep innovation. And when people think about chocolate, they consider making a different sort of Milky Way bar a deep innovation sometimes. And that's not what I'm going to talk to you about. I am going to talk to you about some really deep innovation that has happened. And what you're going to, I hope, be convinced about over the next 40 minutes is that the research we've been doing at Mars, as well as with our collaborators around the world at various universities, is that we've been doing things with cocoa that is changing the way we do business and is going to shift the paradigm of the chocolate sector all around the world forever. So here's the first paradigm change. This was 2005, and this was the front page of the Financial Times. And this is something that is distinctly un-Mars bar or Milky Way bar or Snickers bar. This is that our research, after approximately 15 years, actually found some chemical components in cocoa, which we'll talk about tonight, that have the opportunity to lead to a medical breakthrough. This fellow, Dr. Hollenberg, who you'll hear his name a lot tonight, we've worked with him for about 10 years. He's never worked with the food industry. His research has centered in the pharmaceutical sector, and he's in fact been one of the leaders in hypertension drug development and has been responsible in some part for helping to develop ACE inhibitors. And so he's been working with us because of the fact that this class of chemical compounds that we'll talk about could lead to a major new class of medications. So Mars actually has a pharmaceutical business that has spun out of our research in the chemistry of these compounds. And this is pretty earth-shattering or earth-shaking stuff for our industry to think that is happening. So you may, in the future, think of this fruit tree here, and you guys will know by the time we're done with this lecture that the seeds that come out of this fruit actually might have been the inspiration, and I'm serious when I say that, for a novel class of pharmaceuticals that may be a platform for blood flow related health conditions. And again, we'll talk more specifically about what those may be. The other thing that you guys can talk about to your friends after having seen this presentation is that after many, many decades of the chocolate industry working very hard, and Mars in particular, to develop great snack foods like the Mars bar, we're actually beginning to figure out, on the basis of this research, how to take something that can certainly be part of a healthy diet when consumed in moderation, and actually use science and technology to convert the chocolate into something that can be more than part of a healthy diet when consumed in moderation, but actually can contribute to positive health. Now, where did all that? Those are all grand proclamations that I make, and the base for this is actually what I would suggest to you is one of the leading scientific efforts in recent memory, and hope maybe someday will be regarded as the case study for how a food company rose above the typical level of science that the food industry is known for, and has done not for 1 year, 5 years, or 10 years, but actually for the last 20 years or so has been doing gold standard science by anybody's definition, whether you're in the medical industry or high technology industry or whatever, and I'll show you some evidence of that. The first evidence of it is that based on our publication record, in 2004 we held the first symposium on the science of cocoa at the National Academies in Washington, D.C., and you can see that we had we were in good company in terms of the people who were working with us and appreciated what was happening. And then 2 years later, we held the second symposium at the National Academies in Washington. And again, we're surrounded by a nice group of organizations from around the world who wouldn't have applied their name to the symposium had it not been rooted in gold standard science. And so why was that? The reason is that in a whole variety of areas, and these are representations of some of the publications that are nutrition and medical relevant, and you can see we have the Proceedings of the National Academy of Sciences. This paper we'll talk about a little bit more. This paper from the Journal of the American College of Cardiology, one of the top cardiovascular medicine journals. This paper which looked at understanding how flavanol-rich cocoa could improve blood flow in a certain population, was actually chosen as one of the top papers of the year by this journal. So the work is good, and that's why it's attracting the sort of attention and getting the sort of support that it is. But let's actually step back and let's learn a little bit about cocoa as a plant before we move on to some of the more sexy medical research stuff. So where does cocoa come from? I told you that it's a tree. It's a fruit tree. And this is a nice representation of it. And the origin of cocoa we now know because of geneticists who work in Mars. A fellow named Juan Carlos Montemayor, working with the United States Department of Agriculture, has determined conclusively that the mystery of cocoa, which was thought to have two origins, the myth was that it was two origins, one in Peru and one somewhere north in Mexico, using the most modern genetic fingerprinting technologies, has conclusively shown that no, the actual origin of cacao is in the Amazon basin in somewhere in Peru, in the highlands there. So you've learned a key fact today. So the myth was there were multiple origins for this mystical crop. You now know that no, there's just one origin for this mystical crop, but it's still mystical. Another interesting fact about cocoa, it's grown in the equatorial regions. It can only be grown with just a couple of odd exceptions that don't matter from a commercial perspective. It can only be grown within 20 degrees each side of the equator. Now, it's interesting when you think about that. So this is where cocoa is grown, and this shows biodiversity hotspots. And it's kind of interesting to note that it seems like wherever cocoa can be grown, with the exception of up here and a little bit down there, it also is accompanied by being biodiversity hotspots, and in many places, like West Africa, being political hotspots as well. Just as a fact, again, for you to learn, approximately 70% of the world's supply of cocoa comes from right here, West Africa, Ghana, and the Ivory Coast. Anybody who follows world politics knows that the Ivory Coast is not the most stable place politically in the world. Indonesia, this island called Sulawesi, is also becoming a major producer. Incidentally, that's where a lot of Al-Qaeda camps are and that sort of thing. So it's I can tell you some of the more interesting experiences in my life are traveling to these places. So let's talk about just cocoa itself as preserving biodiversity. This fellow I mentioned to you, Juan Carlos, who works for us and is probably the top cocoa geneticist at this time, he became very exercised about trying to collect wild cacao germplasm, not germplasm, but germplasm. And the reason he wanted to do that is that cocoa is an orphan crop. What that means is that unlike corn or soy or wheat, nobody does any work on it. So if a plant disease is going to ravage corn in the United States, what happens? Well, what happens is that people go into the seed bank, a germplasm bank at the USDA, and they pull out new seed varieties, and we don't really even notice it. In cocoa, very different story. Since nobody's done any research on it, save for what I'm about to show you, it is completely vulnerable to the most simplistic plant diseases and invaders that are out there. It's also very susceptible to man. So what Juan Carlos got very crazy about, and I mean this in a good way, was that he wanted to, in order to preserve the breeding stock for future generations for cocoa research, he wanted to go into the Amazonian highlands and make sure we got this. And so he organized an expedition into these river basins that are difficult to pronounce. And what he did is he and his team actually ended up collecting some wild germplasm that had never been found before, which is really good if you're a breeder. And guess what? It's a good thing he did it, because in 2006 all of this area was clear cut. Okay, so I'm going to talk to you in literally a minute about how cocoa can contribute to stabilizing biodiversity in tropical origins. But, lest we forget, cocoa itself can be a victim of this sort of thing as well. So, fortunately, though, the work was done, and these individuals, the genetic individuals, will be grown up with our support, and will be donated to Peru as part of their national collection. I'm just going to, since we're limited on time, I'll move a little bit quickly. So I mentioned to you, the next point is that we've learned that cocoa farming can, not in all cases, but it can, under certain circumstances, actually contribute to or support both humans in terms of cash crop income in these equatorial regions. This is a big deal. Because cash is hard to come by in some of these places, and cocoa is a fantastic cash crop. but it also can contribute to biodiversity. The reason it can, of course, is that because it comes out of the rainforest, it can do quite well in these sorts of environments. And so it is possible to farm cocoa in almost a rainforest-like setting. And when doing that, it's not the same as preserving biodiversity in virgin rainforest, but it's as close as you can get. And we've done quite a few studies with the likes of the Smithsonian teams and other teams, and what we find is that cocoa farms actually are quite useful in terms of providing habitat for birds and preserving migratory bird corridors, etc. So that's very encouraging. And here's a paper that was published with some West African collaborators. This fellow, Stefan Weisse, runs something called the Sustainable Tree Crops Program in Africa. And the point is that cocoa can provide cash to people who definitely need the cash, and it can be farmed in a way that preserves biodiversity in regions of the world where it's being stripped out. So it's a really encouraging model that we would like to expand. So the conclusion on this piece is that cocoa, as part of the agroforest, can actually be quite useful in terms of socioeconomic contributions as well as environmental ones. Now, last piece in this area is that the fact of the matter is that the parts of the world where cocoa is grown deal with this issue, which is poverty, loss of biodiversity, all the things that I just talked about. And actually, this fellow, that's me, we're in Vietnam. We're in the Central Highlands. Those of you who recall the Vietnam War will recall that the Central Highlands were just completely devastated by napalm, etc. And this fellow right here, Howard Shapiro, who's our director of plant science for Mars Incorporated, has done a lot of things in his life, and one of the things that he's doing right now and that I saw for the first time is that for the past 10 years, Howard has been working with the Vietnamese government as well as other non-governmental organizations around the world, and he's figuring out how to put in cocoa as a cash crop and also other diverse crop species and to actually reforest the Central Highlands. And one of the neat things that he did, people said, can't be done. Howard, cannot be done. And the reason why is because in the Central Highlands, it doesn't rain all the time. It gets really dry sometimes. And so what he did is he said, that's fine, I'll just create lakes, which he did. He's created a series of huge irrigation ponds in this region, and he's demonstrated with the Vietnamese that it can be done economically, and it can capture all the rainfall during rainy season and actually be used to irrigate these farmlands. And so it's quite remarkable. And then these are cocoa clubs. These are cocoa farmers in Vietnam. Who were stimulating so that they learn from each other about how best to grow the crop. So this is important because we need to teach people how to sustainably grow this stuff. Just a little fact is that in West Africa, about 20% of the trees produce 80% of the crop. Imagine if we could teach these farmers and we could provide them with trees that were, 80% of the trees were productive, what that would do to their incomes. It would be really inspiring. And then we love our chocolate, but there are things, I mentioned to you, there are diseases that can affect it. And these are some of the diseases: black pod, you can see why it's called that, frosty pod, and something called witch's broom, because it forms these things in cocoa trees that look like a witch's broom. These diseases are devastating because there is no backup for planting resistant cocoa in these origins. And so what's the one example that is useful to use for people to show how vulnerable cocoa actually is that in 1986 in Brazil, the production of Brazil was 450,000. That's a typo. 450,000 metric tons of cocoa. witch's broom, this disease hit, and by 1996, the production was down to 90,000. So the entire industry was devastated, and there was nothing that could be done. So about this time, Mars and the United States Department of Agriculture, we started an intensive and the only one of its kind breeding program that we dedicated to using the most modern genetic tools without doing transgenics. So there's no transgenic cocoa out there that we know of, but using the most modern genetic tools to accelerate traditional breeding. And so this USDA Mars program is now, after about 10 years, we're at about year 10, we're starting to actually identify, for example, witch's broom resistant cocoa varieties, and we're starting to breed these up. And the importance of this is, think about if witch's broom went from Brazil to West Africa, where 70% of the cocoa in the world is grown. And, in a matter of years, there literally we could experience quite a cocoa shortage. So how does Mars, in addition, help in this? We do put our money where our mouth is. This is actually the Mars Center for Cocoa Science. That's what this box was supposed to say. This is in, but I lost it. This is our research facility in Bahia, Brazil, right in the middle of where this witch's broom disaster hit. And it's the only research center in the world in a cocoa origin that has world-class laboratory facilities. By the way, anybody in this room who's tried to run a laboratory in the tropics will know that it's not easy. The power constantly goes out. The humidity destroys the equipment, and. So it's not easy. But since 1982, we've committed to having this laboratory, and it is there. This is the backside of it. This lady, Regina, she is the mother. She's holding on to one of her children, as she calls them. She's the mother of the most well-characterized and broadest germplasm collection of cocoa in the world, as far as we know, and it's on our research facility there. Okay, just a quick bit on the history of chocolate. One of the things that we respect in science is that it's really important to know what came before, and so in the mid-1990s, Lou Gravetti, who's right here, working again with Howard Shapiro, who in addition to being our director of plant science has a PhD in anthropology, he and Lou came together and decided to actually find out the true history of cocoa. And so this team, which actually isn't everybody, but it's quite a list, came together since 1998 and have been going through all the decaying archives in Panama, Spain, Mexico, Costa Rica, Guatemala, you name it. And we're finding out the true pre-Columbian history of chocolate as well as the post-European contact. And this is a popular quote, but it does give perspective on where we're about to go with the rest of this lecture, which is the health stuff. We see here Thomas Jefferson writing to John Adams about chocolate and its superiority for both health and nourishment. He may well have been right, as we'll find out. This is one of my most favorite findings from Dr. Gravetti. Cocoa flowers were ingredients in perfume baths and used to cure fatigue in government officials and others who held public office. I'm not sure that could relate to academics as well and all sorts of people, but and then we see in France, so after when chocolate and cocoa was taken from the New World to the Old World, we see that it still was really looked at as more of a medicine than as a food. So this will be, now we're going to get into the sexy medical stuff, which is always the most interesting, it seems, and that is The story actually began with some laboratory research that I'll talk to you about in a few moments that intersected with the work I'm going to tell you about right now, which is that there are several populations around the world who are known to, in their isolated home environments, these populations do not experience hypertension. And the Kuna Indians, who live in Panama, are one of these populations. And this was first recorded in the late 1930s by the U.S. Army, who was down there protecting the canal, of course, which is here. And the Kuna lived on the San Blas Islands. And Dr. Norm Hollenberg from Harvard, I mentioned him earlier, his goal in life is to solve hypertension, and he's helped develop some of the most powerful and best pharmaceuticals to treat it. But he would really like to find the genes that cause it. And so he heard about this population, and here's an example of the islands they live on. And he went down to do an experiment to verify, and what he found was that sure enough, what you see is that with the island-dwelling Kuna on those little islands that I showed you, over their lifespan, there was no rise in blood pressure, and you can see it starts pretty low and it stays quite low. And so the percent hypertension is almost non-existent in this population. But his hypothesis and hope that he had found a population who had genes that protected them, or genetics that protected them from hypertension, was shattered because when he looked, here's the island measurements, but when he went to the mainland, this is a suburb in Panama City, and here are Kuna living in Panama City, you can see that hypertension actually does exist. So the conclusion here, as Dr. Hollenberg has published, is that the Kuna do not have genetic protection against hypertension, but there's something in their environment that must protect them. And this is also just one other interesting aspect of the story. This white powder here is salt. Given its proximity to Colombia, there was doubt as to what that was, but it is salt. And what the Kuna do every meal is they use up this salt. And so the Kuna Indians on the island, where there's low blood pressure and no hypertension, consume as much or more salt than most people in this room. Very interesting. Now, what the Kuna genetically are derived from are the ancient civilizations from Mexico. So this is some representations from Dr. Gravetti's work. And what these are, you may sort out, is representations of how the Aztecs and the Mayans view cocoa. And so here's a Mayan doctor mixing up cocoa. And it turns out that an interesting observation is that the Kuna in the islands, here's one of the islands, consume a lot of cocoa, whereas the Kuna on the mainland do not consume cocoa. So this observation is a suggestion. It is not proof, not even close to proof, but it's a suggestion, and it was a suggestion to Dr. Hollenberg that perhaps one of the environmental factors protecting the Kuna on the islands was this dramatic consumption of cocoa. And interestingly, the way that the Kuna consume cocoa on the islands is like I would do when I'm in Brazil or in West Africa or Indonesia, which is I would crack open a pod, and actually I would just eat this, but what they do is they crack open the pod, let it dry in the sun for a while, and then grind it up. What that means is there's almost no processing that they do. So they grind these essentially dried beans out that are very fresh, and then they put them into either the beverage or the main meal that they're going to consume. And why is that important? This is a paper Katie Chavot used to work for us in our analytical chemistry lab. What Mars has done, which I'll demonstrate in a moment, is Mars has developed the gold standard methods to measure something called flavanols in cocoa, and procyanogens are a type of flavanol. And what we found using this methodology is that the cocoa and cocoa beans used by the Kuna are very, very rich in flavanols because the cocoa they use is essentially not processed. And there is a big body of literature which is commonly referred to as the French paradox. And the paradox being that for some reason the French, even though they consume very fatty foods, seem to have less heart disease, or at least in certain regions of France have less heart disease. And the theory is that it's because of wine consumption and because of the colorants in wine, what make red wine red, which are called flavonoids. And that the more flavonoid, or these pigments that are consumed often by wine, then the less heart disease there is. So on the one hand we have the French paradox, and on the other hand we seem to have this Kuna paradox, if you will, building. And as you saw from the previous slide, it could be because of the same family of compounds. These flavonoids, there's thousands of flavonoids, up to 10,000 are known. In cocoa, it is this class right here. Now, in red wine and other fruits and vegetables, there's all kinds of different classes. Anthocyanins are very, very brightly colored purple and red, incidentally. But in cocoa is almost exclusively this type of flavanol. And this is the basic structure, and I don't want to get into a chemistry lecture now, but this is really important. And if you remember the slide I showed you with the Financial Times headline, the reason why Mars is very seriously pursuing one business division in our company, which is a pharmaceutical group, is because of this chemistry that is unique, and we know more about it than anyone in the world. And as you'll see, there's reason to believe it could be the platform for a novel class of pharmaceuticals. So this fellow, René Descartes, said that all progress in science really depends upon the method, and I could not agree with him more. The reason that Mars was able to begin working with Professor Hollenberg, which is obvious now, is that although he could make the epidemiological observation, or the population-based observation, and he could make the observation about the cocoa, what he couldn't do was he couldn't measure what was in the cocoa. And a team led by John Hammerstone, who also now runs our research facility in Brazil. John is widely regarded as the top person in the world for measuring flavanols. And he developed a method. It took about 10 years. It's really hard because each of these little spikes represents a different flavanol. He finally figured out how to separate all these things. And when you can separate something, then what you can do is you can quantify it. And what you can also do is you can isolate these different chemical entities, and you can actually test their biological activity. And while in the pharmaceutical industry this is very common, in the food industry this is not done very much because it's hard work and food is complex. And frankly, it takes more investment than most companies are capable of putting into it. But Mars decided to take the plunge, and for several years we sorted out how to do it. And so by being able to measure these things, what we've been able to do is measure them in cocoa. We've been able to perform clinical trials with this cocoa and actually measure how much of these things go into the body and how much are absorbed into the bloodstream. And then we're able to, after we learn from the clinical trials, this measurement enables us to make products, like actually something you're going to taste a little bit later, a product that actually has a chance and has been shown in clinical trials, gold standard clinical trials, to actually provide a contribution to heart health. So I do happen to be a chemist, so I am biased, but in my opinion, you can't get anywhere unless you can measure something first. Once you can measure it, then you can start going forward, and I think that's been the key to this program. So, what is the mechanism of this interesting biological activity? Well, this was work that we had done. Literally, it was amazing how uncanny the timing was. This was work, although it was published in 2000. This work was done. We had done in 1995, which was about a year or two before we got to know Dr. Hollenberg. And what this work is on the y-axis is the relaxation of a blood vessel in a petri dish. So it's an in vitro assay. And on the y-axis, or on the x-axis here, are different cocoflavanols. So these are essentially code names for different cocoflavanols. But what you see is that, and here's the positive control, what you see is that some cocoflavanols actually are able to relax blood vessels at a level that is as high as a positive control, so pharmaceutical, in the petri dish, whereas other cocoflavanols here were not able to do that. And this actually led us to make a really strategic decision. And I'm going to show you in a pretty picture what this means now. But this gentleman from the German General Staff in the late 1800s noted this, and that's that no plan survives the first 5 minutes of encounter with the enemy, and science is the same. If you're true to the science and you really follow what the data is showing you, then you generally, as good as your plan may be, you oftentimes deviate. Our plan was that we thought the flavonoids and the flavanols would have impact on cancer and preventing cancer. And up until this point, that was our focus. But when that data set that I showed you on the previous slide came in, then although we would love to beat cancer, and cancer does suck, as all of you know in this room, and there's potential that flavanols could help defeat cancer, we realized that the data on that slide actually told us that we need to be studying cardiovascular health and improving heart health and blood flow, because the mechanism was staring us right in the eye. So we changed our strategy, and we focused our biology and our clinical science on the concept that cocoflavanols, some of them, could actually affect the inner lining of blood vessels and could actually protect against the sort of plaque ruptures that can happen that cause strokes and heart attacks and morbidity and mortality. Just with the time flying, I'm going to fly through here and just say that one of the first mechanisms that we found, where we found that cocoflavanols were able to reduce or improve the health of the inner lining of the blood vessel, was a mechanism similar to aspirin. And this is the concept of blood thinning. And so we did a clinical study at University of California, Davis, where we were able to show that blood platelets, or platelets in your blood stream, which generally are not active, these guys get active. They blow up like popcorn. They get active, they get really sticky when there's a wound to cover up, which is good because you don't want to bleed to death. However, when they're overly active, they can cause buildup on your blood vessel lining, and that can lead to heart disease. What we found was that flavanol-rich cocoa could actually it could increase the closure time, and this is a fancy word for increasing the time that it took for blood to clog up a tube, which we used in one of our assays. Bottom line here, without going through all the data on this, note that it is well published, is that flavanol-rich cocoa could actually act much like an aspirin. Now, this gets quite exciting here. This is where I'm going to tell you what the magic of that first mechanism was. And this is work done with Dr. Hollenberg's group at Harvard Medical School. And he recruited a number of subjects, and this measure right here, this is a pen going up and down, and it's measuring the blood flow through a finger on the subject, and each pulse up and down is blood flowing through the finger. And when he would recruit subjects, what he would see is that baseline would be this measurement, and then he would feed his subjects flavanol-rich cocoa that we would provide him. And 60 minutes after that, on the first day, you could see that there was more blood flowing through the finger. Now, interestingly, after 7 days of this, you can see that this person has quite good blood flow going through the finger. And you can see that if we provided a control cocoa, which we always do, that did not have flavanols, then there was, although it still is the blood flow is quite nice, it's not any greater 60 minutes after the consumption, meaning that it seems like the flavanols are the reason why this is happening. Now then what he did was he compared the two baselines. So here's baseline day 1, baseline day 5. So he said, we're seeing quite an effect here over 5 days. And then this is the punchline, and this is what I would like for you guys to remember, is that on the last day of his experiment with this person, day 5, you can see that this person has blood practically spurting out of their finger. Okay, and so cocoa is doing its magic. But when he infused that person with something called L-name, which is a nitric oxide inhibitor, then it all went away. It went down to the bottom. So what does that mean? What have we learned here? We've learned that it's the flavanols in the cocoa that are having the effect, and we've learned that something that blocks nitric oxide synthesis in your blood vessels is the mechanism. Nitric oxide, as many of you probably know, is responsible for winning a Nobel Prize for 3 people in 1998. And it's widely regarded as one of, if not the single most important signaling molecule in blood vessel health. So, there's many pharmaceutical companies who are trying to develop novel molecules to address this mechanism and enhance nitric oxide synthesis. Thanks to the work of Dr. Hollenberg and our chemists and people at UC Davis and elsewhere, we seem to have found a natural substance in cocoa that can have quite a stimulating effect on this important signaling system. And I think you'll get the importance of this when I show you this slide, which is that in diabetes, so here's a type 2 diabetic, comes into Dr. Hollenberg's laboratory. You see the baseline is very poor. After 5 days of cocoa consumption, the baseline of this diabetic is what you would appear to, you'd be saying it reversed the dysfunction in the blood vessel of diabetic. I'm sure most of you know that diabetes is an unpleasant condition, and it's increasing rapidly. And the reason it's very unpleasant is because it is a blood vessel disease. So when diabetics experience kidney failure, blindness, amputation, you name it, and eventually die of heart disease, it's because of the blood vessel disease complications that are brought on by diabetes. So the concept that we might have something that could increase blood flow in diabetics could maybe increase the time before an amputation needs to be carried out in someone who's laying in a hospital bed right now is very exciting. I think now you can probably appreciate why, although we're excited about this from a food perspective, and we have the majority of our business doing that, we're also excited enough to start dedicating research to a traditional pharmaceuticals program to see if we can figure out chemical structures that are novel, but that we can learn from the flavanol structures that could possibly do this in a therapeutic sense. So I am out of time, so I'm sorry, I'm gonna jump through slides here and just get to the very end. This was the PNAS publication, because I know you guys want to taste stuff, so I'm sorry. All of this is really interesting, by the way. Yeah, it'll be available on the Beckman Center website, as I understand. I do want to say something here. So I am from Mars, the company, sometimes the planet. It's always the best introductory line. And in 2002, I think this was. This came out, and the point is, I'm from Mars. I'm from a chocolate company. I'm from the world's largest chocolate company. And I'll tell you right now, I'm not telling you that all the data I just showed you, what you need to do is run out and buy chocolate because that'll prevent diabetes or heart disease. I'm not telling you that. Even though many in the chocolate industry would love for me to say that, but I'm not going to. And so I get really troubled when I see this. And this was an article that I was interviewed for, and the article was actually quite good, even in Vogue. And but these headlines are things to look out for, and I'm not advocating it, and Mars is not advocating it. As great as this data is, this is not the takeaway message. The takeaway message is that there are really interesting compounds that naturally occur in cocoa, and someday we may actually provide products like CocoaVia, which is a very, very small brand that is barely surviving, but someday maybe we'll get the taste right and the messaging right, and there will be chocolate products that can contribute to your health. I just want to end with, how did this happen? All right? What you have seen is rare and maybe unique right now for the food industry in terms of research depth, breadth, and investment. And you should be asking the question, how in the world did a food company, Harold, how have you been able to swim around in basically all the money that is required to pull off a program like this? And the reason is that Mars is a privately held company. We're one of the world's largest privately held companies. And what that means is that we don't have to respond to Wall Street. And so we have this principle. We have these 5 principles, but one of them is called freedom. And what it means is that we stay essentially debt-free, and which is remarkable in and of itself if you guys are into business at all for the size we are. But by being debt-free, it allows us to be able to make decisions about research investments. And so we have been able to sustain this 20-year program on cocoa because we believe that it's our lifeblood ingredient, and that we should lose money for 20 years on cocoa research because in the long term it'll pay off. There aren't many companies like that out there, and so it's a real pleasure from a scientist perspective to be able to work in that environment. And I'd also like to say that cocoa will go away no matter how much money Mars spends on it or other people, unless we can get young researchers out there to help. And we have been working to try and get Nigerians and Ghanaians and Cameroonians and people from these origin countries to get them educated. And the National Academies has a project right now, a 10-year project with the Gates Foundation trying to build capacity in Africa. And I mean, if you guys know scientists in your family, friends, whatever, I would love for you to encourage them to consider getting into cocoa research because we really, really need it, and we need it to be done in some of these origin countries. And here's a plug for the National Academies. Through this Gates program as well as through another program that Rich Bissell heads up, we trained up a Vietnamese student via Mars And this is the young lady, and I met with her when I was in Vietnam this past year. And thanks to Rich Bissell and the National Academy's program with Southeast Asia, she is now going to, she's received a scholarship and is going to study her PhD in the U.S., and she's going to be a future talented cocoa researcher. But I can't tell you, I mean, when you go to these origin countries, and I hope each of you has been or will get the opportunity to, it changes your life when you see what these people, how they struggle each day and what they need to do and how important cocoa is to them. And it puts a different meaning on how important science is, actually. So I would be grateful if you can persuade people to enter the field of cocoa research. Just seeing, this is an important slide as well. These are people who have been the leaders in this research area for the last 20 plus years, plus people like this fellow, this Russian guy. He's the one who developed chromatography, the ability to separate chemicals. He did it in the early 1900s, and had he not developed this methodology, then this crazy guy, Hammerstone, who's now in Brazil, couldn't have used the same platform technology to separate flavanols. Sen-Yorgi actually recognized in the 1940s that flavonoids could contribute to the health of blood vessels. Lee Romancic, longtime Mars scientist, more than 30 years, he actually started this program in 1987. And here's Dr. Hollenberg, of course. And then, of course, I always live by the concept that never think your people are the best in the world. That's why we work with a lot of other people. And I will tell you, here's a little secret information, but I won't actually tell you all of it, but I'll raise your anticipation. A team from Mars and Aachen University will publish an article sometime in the next few weeks that I guarantee you most of you will hear about in the news, and it has to do with clinical data that will build off of some of the things that I talked about just now. So I hope that you have learned the following: that science has shown you that cocoa does not come from two geographical origins, just one. That chocolate was invented to be an indulgence. You know that's not true. You saw the history slides. You know that actually for almost all of its history it's been viewed as a medicine or a medicinal food. You do know actually that cocoa and chocolate have the potential to make a contribution to cardiovascular health. And we'll talk a little bit more about that in real terms up there. One thing we didn't talk about, but I will say, don't get misled by this idea that cocoa content determines how healthy a cocoa is. It's the flavanol content. So in our clinical studies, we use 100% cocoa as our control. That cocoa is a control. It does nothing unless it has cocoa flavanols in it. So please don't be misled by marketing claims that are going around right now. And also please know that the biological actions that I showed you that are so dramatic are not driven by some sort of magical antioxidant capacity. The mechanisms are around nitric oxide and biological mechanisms that are actually independent of this antioxidant story. So I will leave you with that, and thank you very much. I really appreciate the opportunity.